So the first thing I'm going to talk about is modifying the collidable group. I'm just going to go step by step the changes I've made. So when I call set collision pair ship with ship, it takes us to the actual function in the collision manager, which checks to see if the classes we passed in are the same. Those collidable groups addresses are the same, meaning the exact same ones, so ship versus ship. Then I add a test collision with myself. And what that does is add the function collision test, which is different than the templatized one. It just basically checks itself, its own collision group, to see if there's any collisions with any of the other members in that group. And the way I set it up is I have two ships and a weird shape. The ships have the same callback, so you should see it here. Ship to ship, so ship collision with ship. And then the other callback was just ship collision with ship. So ship collision with weird shape and weird ship collision with ship. That's just to show that everything works, even the two collides for the same class. Okay, so now I'm going to show the actual collision testing. I added a collision model and a matrix to the collidable. Okay. And then I set that world, the collidable's world, to the world which I use for the graphics object, because it would make sense, you want them to be overlapping. And then in the actual collision testing, I basically have the initial radius, initial center, and then the arbitrary vector, which of unit length 1. And then I get the length between the initial center and the arbitrary vector, so I can use that as a reference for the scaling factor. Then I transform the center and the arbitrary vector, sorry for the typo, it should be a center, by that world transform. And then to find the scaling factor, I find the distance between the new center and the transformed vector, which could be considered a position. And then you divide by the initial scale, you will get the scaling factor. I do that for B as well, and then to get the distance, I get the distance between the new center and the new center for the collidables in question. And then to get the radius added, I get that scale factor times the initial radius, and then add it to the other collidables scale factor times the radius. And then if the distance is less than the radius added, it should return true, as in there was a collision. So I'm going to check it with this one way in the back just to make sure that the scale factor does work. Okay, so as you can see, and just to note, the scale has been reduced by 0.5. So if we look at the distance between that collision, it's 44.02, and the radius added is 44.17. So it did in fact collide, which is why the breakpoint happened. The initial radius for the ship, because they're both ships, will be the same. So it's 44.16, and because I said that scaling factor was 0.5, that's also correct. The radius added should just be the initial, and there you go. There is a little bit of loss, but that's only because of the float computation, not the algorithm itself. And then to show it visually, so it happened. As you can see, the distance is less than the radius added. And then, if you look, it is in fact colliding. And so the next thing I'm going to talk about is the terminable class, and that's basically it's got a bool for the mark for termination, and it's got the onTerminate, which is a virtual function that will be that the user will override. And then we have the mark for destroyed, which is just calling the scene manager to register this object in its terminable manager. And the terminable manager, all it does is pretty much allows registration and then processes terminations that have been registered, which is in its terminable list. So register is just if it has been marked for termination already, then set the termination equal to true, and then push that terminable object into the actual list. And then in the process termination, all it does is, while the terminable list isn't empty, then it'll delete and free it up from memory, and then remove the pointer. So the way I tested it is basically on collision. Sorry. Let's get this really fast. So when the ship collides with itself, it should mark for destroy. So when two ships are colliding with one another, they will both be destroyed. And also with the weird shape, I forgot to mention really fast. When it's iterating through that list, it'll call on terminate, which is that callback function. So in this case, when there's a collision, the ship-to-ship collision or ship-to-weird shape collision, it'll call mark for destroy on the ship, and then because of the callback, it'll call on terminate, and this is where I free up the kind of memory I've used for the ship, and I deregister for updating and collision. So just to show that it does work, I'm going to have both ships disappearing first, and that's just on collision. So there we go, no crashing. And then the same for the weird shape. For the weird shape, I only have the ship destroying itself, not the weird shape. So there you go. So that's pretty much everything for the sprint, I think. So that's all up and running. The final thing actually is just making sure that those virtual destructors get called, and I basically have a breakpoint at each destructor. So I'll just destroy ship, and then it'll just go up the hierarchy, or it's weird, I don't know why that's there. Okay, so actually I'll just go with the weird shape. The ship will be destroyed. So it'll mark for destroy, and then that'll get processed in the terminable update. So it'll get the ship, which is the derived class, then the game object, and then it goes to the terminable, alarmable, drawable, updatable, inputable, collidable, and that's it.